This video lecture is from Chapter 4, Section 3, and covers the objectives that say that you can define the terms atomic number and mass number, and you can calculate the number of protons, neutrons, and electrons in an atom. You should have a handout that looks like this. You can find it in the handout section of my website. We are actually going to start down near the bottom of this handout where it says atomic number. Atomic number is defined as the number of protons in an atom. If you were to look at a periodic table, each of the element boxes has a whole number associated with it, a unique whole number associated with it. It is this whole number that represents the atomic number. So it is a whole number on the periodic table. The atomic number is what establishes the identity of the element. So if we were to look at this diagram over here on the right side of the paper, you would see that it has 3 protons in the nucleus. 1, 2, 3. So that means that this atom has an atomic number of 3. If I were to look on a periodic table, find atomic number 3, it's on the upper left-hand side of the periodic table, you would see it is the element lithium. So the symbol is Li, and to indicate the atomic number, we put that number 3 in the lower left corner of that symbol. Now, if we were to count all of the particles in the nucleus, all the protons and all the neutrons, that's a total of 6 in this particular individual atom of lithium. So we would put that number 6 in the upper left corner of the periodic table. And this number is referred to as the mass number. The mass number is defined as the number of protons and neutrons. Since the protons and the neutrons have almost all of the mass of the atom, that's why it's referred to as the mass number. You will take note that you can't have a fraction of a proton or a fraction of a neutron, so therefore a mass number must be a whole number. And if you were to consider looking at the periodic table, if you happen to have a periodic table handy, there's only one whole number associated with each element, and that whole number is the atomic number. So the other number that you see that has a decimal is not considered to be the mass number, but we'll talk about what that number means in a different lecture. Going back to the mass number. So mass number is the number of protons and neutrons in the nucleus. It has to be a whole number, and it represents the mass of an individual atom. So if we were to go back to this symbol that I had you write down, mass number of 6, atomic number of 3, if all I gave you was this information, you could easily calculate the number of neutrons by subtracting the mass number minus the atomic number. Okay, so the number of neutrons can be found if you take the mass number, subtract the atomic number. That would give you the number of neutrons. Now, in any given, anytime the word atom is used, there's an implication that that means that particle is neutral. And in order for a particle to be neutral, the number of positive particles has to be equal to the number of negative particles. Well, electrons are negatively charged. Protons are positively charged. So if the number of electrons equals the number of protons, then the atom will be neutral. Going back to the top of this chart, the top of the page, and what we can see here is a chart that's meant to be filled out. So here we see hydrogen is the element name. The atomic symbol for hydrogen is H. From a periodic table, we see that the atomic number is 1. If it has an atomic number of 1, it means that we have 1 proton. And we then put that number in the lower left corner of the symbol. Now what I see here, if I skip over to where it says mass number belongs in the upper left corner of the symbol. And from this, once we have the mass number written in, it's pretty easy to see that if you subtract 1 from 1 to give you the number of neutrons to be 0. Finding the number of electrons, these are all atoms that are meant to be neutral, which means that the number of protons and the number of electrons have to be equal. So in this case, the number of electrons will be 1. Second example, helium. Helium has the symbol He. From the periodic table, we see it has an atomic number of 2, which means it has 2 protons. We put that number in the lower left corner of the symbol. We then take the mass number of 4, put it in the upper left corner, and from that we can see the mass number being protons and neutrons, subtracting out the number of protons, in this case 2. 4 minus 2 gives us 2 neutrons. Number of electrons in this case will be 2, because the number of electrons have to equal the number of protons. Positives and negatives, if they are equal, of course the atom will be neutral. Lithium has a symbol Li. It has an atomic number of 3, which means it has 3 protons, so we'll put that number in the lower left corner. We'll notice that the mass number of 7 goes in the upper left corner, and from that we can see 7 minus 3 will give us 4 neutrons. 3 protons, 3 electrons will make this a neutral atom. Beryllium has the symbol Be. It has an atomic number of 4, which means it has 4 protons, and we'll put that 4 in the lower left corner. The mass number of 9 goes in the upper left corner. 9 minus 4 gives us 5 neutrons, 4 protons, 4 electrons. Boron has the symbol B, atomic number 5. And again, the atomic numbers are all coming from the periodic table. They're not just numbers I'm making up as we go. Okay. Atomic number 5 means we have 5 protons. We'll put that number in the lower left corner. Mass number of 11 goes in the upper left corner, which means 6 neutrons. 5 protons means we should have 5 electrons. Carbon, symbol is C. Atomic number 6. We're going to put that number in the lower left corner. Mass number of 12 goes in the upper left corner. 12 minus 6 gives us 6 neutrons. 6 protons, 6 electrons makes this atom neutral. Nitrogen, symbol N. I used the wrong color and I don't like that. Going back to blue. Nitrogen has the atomic number 7. In this case, the mass number is told to us to be 14. 14 minus 7 gives us 7 neutrons. 7 protons and 7 electrons will make this atom neutral. Oxygen, symbol O, has an atomic number of 8. We're told here that the mass number is 16. 16 minus 8 will give us 8 neutrons. 8 protons, 8 electrons makes this neutral. Fluorine has the symbol F, atomic number 9. We're told here that the mass number is 19, which gives us 10 neutrons. 9 protons, 9 electrons makes this neutral.